Cos of theta is 3/8, and it's not in quadrant 1. So this is going to be a triangle question. And because cos is positive and it's not in quadrant 1, that means it has to be in quadrant 4. So we can draw it. We can draw a triangle with our reference angle back to the nearest x-axis, and we can label that the adjacent over hypotenuse would be 3/8. If we do a squared plus b squared equals c squared, 64 minus 9 is 55. So that'll be the square root of 55 for the other side. Now that we have that triangle, it's going to be easy for us to say, well, sine of theta in quadrant 4 is negative, and sine is opposite over hypotenuse. And tan of theta is also negative in quadrant 4, and it's going to be opposite over adjacent. So again, that's not the only way that you could solve this question, but I do find that drawing the triangle is often a quick way and an easy way to figure these questions out. Question number 2. Is that point on the unit circle? Well, it's not on the unit circle as far as one of our memorized values. So if you check all the points that we labeled on our unit circle, it's not on there as one of our memorized ones. But it might be one of the points in between that we didn't label. So how do we find out whether or not that point is on the unit circle? Well, if it is on the unit circle, this would have to be cos of theta, and this would have to be sine of theta. So for every angle there exists, on the unit circle, the x-coordinate is always cos of theta, and the y-coordinate is sine of theta. So one of the things we'd have to check here is, do these two go together? So if we draw a triangle for this one, first of all, can you tell that since both of them are positive, it would have to be in quadrant 1. So I could draw an angle in quadrant 1. And let's just start with cos. If we label things with cos, it's telling us that the adjacent side is 3 and the adjacent side is square root of 3 and the hypotenuse is 3. A squared plus b squared equals c squared. We're going to solve for this side here. We would have to do root 3 squared plus b squared equals 3 squared. So I get 3 plus b squared equals 9. B squared equals 6. Now, when you take the square root of both sides, normally you do plus or minus, but since we're talking about a length here, it makes sense to write only the positive value, square root of 6. So if we solve for this side, we get square root of 6. Does that match? Does sine of theta equal root 6 over 3 on that triangle? Yes. So since we solved for this side and it matched that sine of theta here is root 6 over 3, we can say yes, this point is on the unit circle. If we got square root of 7 or square root of 8 or something that didn't match with what the point was, then we would say that no, it's not on the unit circle. Another way that people also like to solve this question, the first time we solved this question, we used the big idea that the x-coordinate was cos, the y-coordinate was sine, and we drew the triangle and found out that it worked. Another big idea that we can use to solve this question is to check if it's on the unit circle, sine squared of theta plus cos squared of theta should equal 1. Well, according to this, sine was root 6 over 3. If we squared that, and cos was root 3 over 3, and we squared that, what do we get? Well, square root of 6 times square root of 6 is 6. 3 times 3 is 9. Square root of 3 times square root of 3 is 3. 3 times 3 is 9. We add this up. It equals 1, so we know it's on the unit circle. So that would be another way that you could show the answer for this. You could either show that sine squared plus cos squared equals 1, so then those points are sine and cos, or you could show from your triangle that for that angle, those are the right values for sine and cos. For the last question here, if negative 12 over 13 comma y is on the unit circle, find the coordinates of y. So if it's on the unit circle, then this is cos theta. And if it's in quadrant 3, we can draw a triangle, label our reference angle, and since we know cos of theta is 12 over 13, we can label that side. Recognize that triangle? What's the other side? A squared plus b squared equals c squared. This is another one that works out nicely. 5, 12, 13. So if the x-coordinate is cos of theta, our y-coordinate will equal sine of theta. So our y-coordinate will be opposite over hypotenuse, and because it's in quadrant 3, it will be negative. Next thing we're going to be looking at is taking angles and coterminal angles, especially big angles, and figuring out where they end. So for example, if we have a big angle like 4,300 degrees, we might want to find out what quadrant that's in, and then we're going to find the first coterminal angle that ends in the same place as 4,300 degrees. Now if you have your calculator, and for most part of your test you won't have your calculator, but if you did have your calculator and wanted to figure out what quadrant it's in, if you take 4,300 degrees and divide it by 360, you get 11.94. And that 11.94 means that it's gone 11 full times around, and then it's gone another 0.94, or another 94% around again. Does that make sense that that would end in quadrant 4? Because you went 11 full times around, and when you go that last time around, go 94% around, it's going to end somewhere in quadrant 4. Does it make sense if that decimal is 0.25, it would end somewhere in quadrant 1? Somewhere between 0.25 and 0.5 in quadrant 2, 0.5 and 0.75 in quadrant 3, as is listed there. But for the most often you won't have a calculator. So what you're going to have to do is you're going to have to say, well, how do I know where this ends up? And if I want to write a coterminal angle, the very first positive coterminal angle that ends in the same place as 4,300, how would I do that? Well, you could start with 4,300 and subtract 361s, and then subtract 360 again, and subtract 360 one at a time until you get an answer that's between 0 and 360 degrees. That would work. It just would be tedious to do one at a time. If I was doing this without a calculator, I'd probably subtract 10 360s right away. Does that make sense? 10 times 360, 3,600. And see what I have left now? Well, now I have 700. That's still too much. So I would subtract another 360. Until I got to 340 degrees. And then I could say that 340 degrees is coterminal with 4,300. Now with degrees, you're used to degrees, adding and subtracting. 360 is not bad. But with radians, for the most part, our questions with radians will have a pi in it. So if we had something like negative 23 pi over 6, it'll most likely be a non-calculator question, and you need to find out where it ends. So what we're going to do as a strategy is we're going to change the negative 23 over 6 to a mixed fraction. How many full sixes are there in 23? There would be 3, because 3 times 6 is 18. There's 5 left to make 23. So we could write that negative 23 over 6 is equal to negative 3 and 5/6. Now, changing it to a mixed number is going to help us, because if we think about our unit circle, and we start here at 0, halfway around is pi, all the way around is 2 pi. If you're at 2 pi and you went another halfway around, you would get to 3 pi. And if you went another halfway around, you'd get to 4 pi. And over here, you'd get 5 pi, and so on and so forth. Do you see a pattern? Do you see that on this side, they're all even, and on this side, they're all odd? So when we have negative 3 and 5/6 pi, and we're trying to figure out where that ends. Well, first of all, negative would start here and go in this direction. And this would be negative 1 pi, negative 2 pi. Negative 3 pi would get us to there. And now we're looking for, is the fraction that's part of the mixed fraction, is that fraction bigger than a half or less than a half? It's bigger than a half, so we have to go past, and it's going to end in quadrant 1. And once you know what quadrant it ends in, you just have to think about your pi plate and say what family member would be in that quadrant. We're dealing with a pi over 6 angle. What's the pi over 6 angle in quadrant 1? It's going to be coterminal with just pi over 6. Let's try another one. (19 pi over 4). If you change that into a mixed fraction, can you see that you would get 4 3/4? Think about your unit circle. 4 would get you to here. 1, 2, 3, 4. 3/4 is more than half. This is going to end in quadrant 2. What is your pi over 4 family member in quadrant 2? (3 pi over 4). So 3 pi over 4 is coterminal with 19 pi over 4. How big a number do you want? Not too big? How about something like 43 pi over 6? As a mixed fraction, what would that be? (7 1/6). Can you see that 7 is going to end here? Because it's an odd number. And since we're going positive direction, 1/6 is less than half, so it'll just go a little bit more and end in quadrant 3. What's your pi over 6 family member in quadrant 3? 7 pi over 6. So 43 pi over 6 is coterminal with 7 pi over 6.